Section 10.5, we're looking at harder trig equations, and the absolute key here is don't even think about doing section 10.5 unless you are thoroughly happy with section 10.4. What we're going to do here is tack something onto the start of the technique for section 10.4, and I'm only going to do these questions until they turn into section 10.4 questions. I'm only going to do the first couple of stages, and they work like this. If I've got a question that looks like this, 0.766 in the interval 0 to 360. Well, the problem I've got here is this bit. I can solve equations that look like cos of x equals 0.766 in an interval, but not when I've got a 3 theta there instead of an x. So the method we're going to use is almost as simple as it could be. I'm going to say, well, I don't want a 3 theta there, I want an x. So let's change 3 theta into x. Now that's why I'm using a capital X here, because sometimes this is written in terms of theta, sometimes it's little x. So I always tend to turn them into a capital X, and you'll see other textbooks. In fact, that's the technique. I'm just looking. That's the technique that this textbook uses. They use a capital X as the symbol here. So that capital X is replacing an expression here. Okay, so when the input to your cos function isn't just a theta or an x, replace that input with your capital X. Okay, and then what have we got? Well, cos x equals 0.766. Great, that's an equation that we can solve, except these equations aren't on their own, they come with an interval as well. So when theta equals 0, well, big X is 3 times 0, so actually the smallest value that big X can take is 3 times the smallest value that theta can take, which is 0 degrees, so that's easy. When theta equals 360, well, big X can be 3 lots of theta. So the biggest value that big X can take is 3 lots of 360, so big X can go all the way up to 1080 degrees, okay? But that's fine. We're solving cos X equals 0.766 in this interval, and that is now an equation that we can deal with. So how would we do that? Well, we will take our cos graph, starts at 1, 360, 720, oh, I'm going to have to squeeze one in, never mind, there we go, 1080, sorry that's a bit scruffy, but there we go. 0.766, I get one solution from the cos inverse of 0.766, and I'm just going to cheat and get that one out of the book. That says it's roughly 40 degrees. Okay, so that one there is 40 degrees. Then I've got this solution here, this solution here, this solution here, this solution here, and this solution here. Okay, so I've got 1, 2, 3, 4, 5 more solutions. And now I need to work out what these solutions are. Well, this is, when sketching my graph, I really should have put this on already, but 180, 270, 360 degrees. Right, so this one here, that gap there is 40 degrees. That's 40 degrees from the top of the curve. That's 50 degrees from the point where this crosses the axis. Now, here you can see the problem with sketching the graph. That gap there is 50 degrees, and that there is 40 degrees, and that looks wrong, but just because I've sketched it quickly. Don't panic if that's the way it works, just make sure you are thinking about this is the x-axis crossing point, this is the top of the curve. So 360 take away 40 would give me this solution here, 360 add 40 would give me this solution here, and I'm working from the top of the curve, and here I was working from the top of the curve. If you want to go from the x-axis crossing points, 270 plus 50 will give you this solution here, and this is 450 take away 50. Okay, so in that way we can get 1, 2, 3, 4, 5 other solutions, and because we've done that bit in the last section, I'm just going to write those ones down. 400, 680, 760, and 1040. Now the mistake that people make in the exam is to say, great, there we go, I've got the solutions to my question. You can stop making that mistake by going for the old technique of read the question, do the question, then read the question again. And what's happening here is, look, we've got the capital X, but we were asked for theta. So we need to change this into 3 theta equals 40, 320, 400, 680, 760, and 1040. And if that's 3 theta, then the theta that we're looking for is 1/3 of each of these things. So theta is 13.3, 107, and so on. All right. So a third of 320, 107-ish. So need to take each of those numbers and divide them by 3. Okay. 760 divided by 3. Wow, I keep deciding not to write these down, and then I'm writing them down. 347. So those are the answers for our thetas. Okay. Now, the other thing that they're asking us to do in this section is they're giving us an example where we don't have one trig equation, trig identity. We need to turn it into an equation that looks like this. Sine or cos or tan of our unknown equals a number. What if we've got sines and coses? Well, that's no good. That doesn't fit our pattern. It doesn't fit going back to section 10.4. We have to have either just a sine or a cos or a tan. But fortunately, we have trig identities. I know that if I take this equation here and I divide through by cos on both sides, I get tan 2 theta equals 1. So sine divided by cos is tan. So if I divide through by cos 2 theta, I get tan on this side. Cos 2 theta divided by cos 2 theta is 1. And then if I divide through by 2, now this looks like one of these equations. And just for completeness, the theta here goes from 0 to 360 again. So this equation I can now solve using the technique that we used here. And the technique that we use here involves changing the 2 theta into a capital X and then using the technique from section 10.4. So if there's more than one trig ratio in it, if there's sines and coses or coses and tans or whatever, then find a way of turning it into just one trig ratio. If the input into your trig ratio is not a single theta or a single x, then substitute in a capital X and change the limits. When you change the variable, you change the limits, and we work from there. Okay, change the variable, change the limits is a phrase that we're going to see a lot. And just for completeness, what if I have something like this? Sine of x plus 60 degrees equals 0.3. Well, let's think about it. In the interval 0 to 360. Well, I've only got sine. It's not sine and cos and tan, there's just sine, so that's fine. But my input to my sine isn't just an x, it's an x plus 360. So I use this technique. When little x is 0, capital X equals x plus 60 degrees, not x plus 360 degrees. So whatever was in there, I change it into a capital X. When little x is 0, big X is 60 degrees. When little x is 360, big X is 420. So I'm trying to solve that equation in that interval. When I've got the big X solutions out, so I do a section 10.4 question there, and I get the solutions out, and then I need to convert my capital X's back to little x's by taking away 60 from each of my answers. Okay. So if you look through section exercise 10e, and perhaps I'm labouring the point here, stop the video and go for it if you think you've got it. If you've got a sine and a cos, or a cos and a tan, so I'm looking at section question 3 on exercise 10e, page 218. You need to mess around with the trig identities until you've only got sine or cos or tan involved in those questions. When you've done that, if the input is not a single variable, then substitute in your capital X. When you change the variable, you change the limits, so change the limits on the equation as well. Now you should have a straightforward question because you've practiced section 10.4 until it's easy. Then convert your capital X's back into the variable that you wanted. And that is everything in section 10.5. And we're nearly at the end of the chapter.